Hi Nat5. So what we're going to do today is every sort of lesson that we do online from now on, I'm going to give you a starter. You guys are going to do it, and then once we've done the starter, we'll carry on with the course. So our starter today, because I'm sharing this video to all my Nat5 classes, so that's my third years and my fourth and fifth years, I've split the starters into two. So S3 and S4 and S5, so everybody does these two questions here, and then my S4s and S5s, I want you to do question 3. Third years, you can't do that, okay, so just leave that. So what I want you to do, I want you to pause this video and I want you to attempt the starter, because in about 10 seconds I'm going to go over it, okay? So pause the starter, pause this video, do the starter, and then unpause it. Right, so very first question then, write the formula for strontium hydroxide. So because it's not got a prefix, there's no mono, di, tri, tetra, etc. We need to use SVSSF, okay? Because it's strontium hydroxide, our symbols are SR for strontium and OH for hydroxide. That's a group ion, so it's OH. Now strontium's in group 2, so it's got a valency of 2. Hydroxide, you would need to have used page 8 of the data booklet, that's in column 1, so that's got a valency of 1. They don't simplify, we swap them over, so that's 1 and 2. So our formula is SR, and remember what I said, if you've got more than one group ion, you need to place it in a bracket and then put the 2 outside. Okay, so that's our formula for that one. For so that's A. For B, lithium phosphate, it's the same idea. Okay, so we still need to do SVSSF. So our symbols are Li for lithium and PO4 for phosphate. Okay, again it ends in 8, so it's a group ion. You would need to have used the data book for that. Now the valency for lithium is in group 1, so that's 1. Phosphate, you would need to use page 8 of the data booklet, that's in column 3, so that would have a valency of 3. They don't simplify, swap them over, so that's 3 and 1. So our formula is Li3PO4. Okay, now you can either have it like that, or if you put the brackets in but just left it like that, that's also fine, it doesn't really matter. But yeah, that's it. Right, as for this one here, finding our pen. So the number of protons is 11, because that there is our atomic number, and the atomic number always tells us the number of protons. This positive charge here tells us that we've got more protons than we do electrons, so we've got 1 more proton than we do electrons. So if we've got 11 protons, we must have 10 electrons. Okay, and to get the number of neutrons, you do the mass number 23, take away the atomic number 11, so the number of neutrons we have is 12. Okay, so 11 protons, 10 electrons and 12 neutrons. Right, so third years, that's your starter done. I'm just going to quickly do the starter for the S4, S5s, and then we'll start with the course. So guys, because we're working out mass, you would have needed to have rearranged your N equals M over GFM equation to get this. M equals N times GFM. The number of moles we have is 1.5. The GFM, you would had to have done this for ammonia, which is NH3, so 3 hydrogen would be 3, 1 nitrogen would be 14, so in total we've got 17. So the answer is 1.5 times 17, and if we do that, that would be 25.5 grams. Okay, so well done if you got that. Right, what we're going to do now is my favourite topic, which is bonding. And how this is going to work is you are basically going to write down everything that I write down. Okay, so you'll need to get your study tutorial jotter out. So if you don't, you'll need to pause this video, get your jotter out, and whatever I write down, you need to write down as well, and that's how we'll do it. Okay, and then when I come back, I'll get your active notes, and we'll fill them in. Okay, so first things first, get your study tutorial jotters ready and get this heading bonding. So, in compounds and elements, the atoms are held together by bonds. Okay, so make sure you're getting this down. Now, you all know what an element is. Yeah, it's the elements that make up the periodic table. You have oxygen, that's an element. Nitrogen, that's an element. An element is just something that's made up of one type of atom. Okay, so oxygen's made up of oxygen atoms. Nitrogen's made up of nitrogen atoms. Yeah, so maybe make a wee note there. Elements are made up of one type of atom. Yeah, the wee example, like I said, oxygen is made up of oxygen atoms. Yeah, relatively straightforward. Iron is made up of iron atoms. Calcium made up of calcium atoms. Now, compounds, on the other hand, compounds are made up of two or more different type of atoms. Now, what I mean there is if we go for, let's just go for lithium chloride. Okay, now lithium chloride is a compound because it's made up of lithium atoms and chlorine atoms. Okay, so lithium chloride is a compound as it is made up of lithium and chlorine atoms. Okay, and that's your two or more different type of atoms. Okay, right, now this is the important part. Okay, this is us getting into the sort of the bonding side of it. So there are three types of bonding in chemistry, and we'll talk about what they are. Okay, now I'm aware that the fourth years will already know this, but we're starting from scratch again, almost as if you haven't done it before. So the first type is metallic bonding. Okay. The second type is covalent bonding, and the third type is ionic bonding. Okay, so what we're going to do is I'm going to go through each one of these: metallic bonding, covalent bonding and ionic bonding. Okay, I won't get through them all today. I'll maybe just get metallic done, I might maybe be able to start covalent. I'll see how it goes, but we certainly won't get them all finished today. Okay, so let's start with the first one, which is metallic bonding. Now you'll probably already be able to guess what this means, metallic bonding, but I'm going to go through it anyway. Okay, so metallic bonding is found in metals. Okay, and that to me seems quite obvious. Yeah, metallic found in metals. So metallic bonding is found in metals. So I'll do a wee example. Iron contains metallic bonding. Because iron is a metal, it's to the left hand side of the stairs. If you look up your periodic table, those sort of stairs that go up, that separates your metals and non-metals. So the metals are found to the left of those stairs, the non-metals are found to the right. So metallic bonding is found in metals, so iron contains metallic bonding. Okay, now this wee bit here's probably the most important part, is only, sorry, let's got that out. You can only get metallic bonding in metal elements. Okay, you'll know what I mean when we start going through this. So you can only get metallic bonding in metal elements. Metal compounds do not exist. So what we mean by that, you can only get metallic bonding in metal elements. So you can get metallic bonding in iron, you can get it in magnesium, you can get it in calcium, you can get it in every single metal element, but you can't bond two metals together. Okay, that's physically impossible to do. Okay, so what we can do, however, is we can mix them. So metal elements can be mixed together. And I don't know if you know the name of it. You certainly probably would have heard it if you've like if your parents or guardians have a car. But metal elements can be mixed together. We call this an alloy. Okay, and that's very important. So remember, we can't bond metal elements together, but we can mix them together. Right, let's say, so I'll let you sort of just get caught up there. That's a wee introduction to metallic bonding. So we're going to stick with metallic bonding. So let's carry on. So in all types of bonding, not just metallic, the atoms want to achieve a full outer shell of electrons. Okay, so in all types of bonding, not just metallic, the atoms want to achieve a full outer shell of electrons. Okay, we've discussed this already when we spoke about ions. how ions always have a full outer shell because they want to be stable. Okay, so all atoms want to achieve a full outer shell of electrons. This causes them to be stable. Okay, and that's all atoms want. They want to be stable. And how do they become stable? By getting a full outer shell of electrons. Now, what I mean by that, just in case you can't remember from the previous topic, let's go for let's just go for oxygen. Yeah, that's a favourite of mine. So oxygen has the electron arrangement 2, 6. Yeah, so oxygen's got 8 electrons, so 2 go into the first shell and then 6 go into the second. Okay, now if we look at I've not got a data book with me, I think it's neon. Neon has 10 electrons and that's got an electron arrangement of 2, 8. So 2 in the first shell, 8 in the second shell. Now, neon is what we would call stable, and oxygen is what we would call unstable. Okay, so the oxygen atom, because it hasn't got a full outer shell, now remember, if we sort of do what we did previously, in the first shell, you can get a max of 2 electrons. In the second shell, you can get a max of 8 electrons, and in the third shell, you can also get a max of 8 electrons. Okay, so in order for an atom to become stable, its outer shell must be full. Okay, so because oxygen's outer shell can have 8, it only has 6 electrons, it's unstable. Because neon's outer shell has 8 and the max it can fit is 8, that's a full outer shell, so neon we would classify as stable. Okay, and it might just be worth noting here is that all noble gases are stable. Yeah, that's your, if you can't remember, that's your group 8/0, depending on what periodic table you look at. All noble gases are stable. They've got a full outer shell of electrons, and that's important. Okay. Due to having a full outer shell, noble gases do not bond. Okay, and the reason they don't bond is because they've already got a full outer shell, and the whole point of bonding is so atoms can get that full outer shell. Okay, that's why atoms bond, because they want to become stable, they want that full outer shell. Right, anyway, let's get back to metallic bonding. Okay, so metallic bonding continued. Now, metals bond by losing, okay, and this is very important, okay, so it's very important not to get this mixed up. Metals bond by losing their outer electrons to become stable. So if we pick a metal, just off the top of my head, let's go for lithium. So lithium has 3 electrons, with an electron arrangement 2, 1. So what happens there is lithium loses 1 electron to have a stable electron arrangement of 2. Okay, so now what we've got is we've got lithium with 2 and we've got a free moving electron. Okay, that electron's just, oh sorry, can't see that. So we've got an electron arrangement 2 and we've got this free moving electron which is just allowed to move about, but I'll go into more detail in that in a wee while. So we've got lithium Li, because it's lost an electron, that goes to Li plus, and you've already done ions, so hopefully that's familiar to you. If we go for another sort of example, let's go for magnesium. Okay, magnesium has 12 electrons, so it's got a 2 in the first shell, 8 in the second and 2 in the third, and you can find these on page 6 on the data booklet. So 282, that is your magnesium atom. And have a wee think, okay, before I put the answer in, how many electrons do you think magnesium has to lose in order to have a full outer shell? Okay, well, it would have to lose 2 electrons. So if it loses 2 electrons, what happens is that goes to 2, 8, and we've now got a full outer shell, because remember in the second shell the max you can have is 8 electrons. Okay, and again, because magnesium's lost 2 electrons, that'll give it a charge of Mg2+, because we've now got 2 more protons than we do electrons. Now remember, those electrons are lost, so we've got 2 free moving electrons. Yeah? Right. Remember, if I'm going too fast, you can pause this video anytime you want and you can get caught up. Okay, just make sure you're getting everything down. Right, let's go on to the next page. We're going to talk about the free moving electrons. Okay, so let's just pick a... use my different pen. Let's just pick sodium. So sodium has 11 electrons, so that's got a 2, 8, 1. So in order for sodium to become stable, what it would have to do is it would have to lose one electron to become 2, 8. Okay, so we're going from Na to Na plus, and because we've lost an electron, we've got that free moving electron. So that electron's able to move wherever it wants, and that there is so important. Now, just make a wee note here. We call free moving electrons delocalized. Okay, so if an electron's allowed to move freely, we call it delocalized. Okay, very important, that word. So what we've got now, oh sorry, I forgot to put my plus there. So it's went from sodium to sodium plus. Okay, so we call free moving electrons delocalized. And I just want to point out that this here, I mean this is pretty obvious because you've already done it, but this here is called a positive ion. Okay, remember ions are called charged particles, so if we've got a charge, it's an ion. This is a positive ion because it's got more protons than it does electrons now. Okay? Right. So, metal atoms are arranged in a lattice structure. Okay, and what we mean by lattice is just a sort of a repeating structure in every direction. Okay, so it repeats going up the way and it repeats going to the left. So what I mean by that is that's one atom. Okay, that's 2 atoms, 3 atoms, 4, 5, 6, 7, 8, 9, 10, 11 atoms. Okay, now because it's a lattice, what we mean by that is that repeats going in that direction and it repeats going in that direction. I just don't have enough paper to draw them all. Now, this is the hard part. This is where it starts to get a wee bit tricky. Now, because we've lost an electron, yeah, but we're now stable, but we've got a positive ion. So, because we've got a positive ion, at the centre of all these atoms, we've got to write a positive sign. Okay, so that tells us all these ions here are positive. Yeah? Now, for every atom that's lost an electron, we've got 1 electron, free moving electron. Yeah? So if we've got 11 atoms here, 11 atoms have lost 11 electrons essentially. These electrons are then scattered throughout the structure. Yeah? So these electrons are now scattered away, and what's important is that they're delocalized. And what do we mean by delocalized? They're free moving. Okay, so these electrons are free to move, and what they do is they like to move in the same direction. Okay, and they like to move sort of the way I'm drawing it, like so. Okay, so all these electrons like to move in a sort of wave-like structure. Okay, and what we like to call that, because it looks like a wave, it looks like an ocean, we call that the sea of electrons. Okay, so let's make a wee note on this. The delocalized electrons are free to move within the lattice. Yeah, that's what we call that. We call that a lattice structure. So are free to move within the lattice structure, and we call them the sea of electrons. Oh, sorry, helps if I can spell. We'll call this the sea of electrons. Yeah, and that's just because it looks like, well, looks like the ocean, looks like the sea. Yeah, the waves going like that. So yeah, that's it. We call that the sea of electrons. Now you should know electrons have a negative charge. And you should also know, have a wee think, what happens when we have a negative charge and a positive charge. Have a wee think. Okay. So you should know that positive and negatives attract. Therefore, the positive ions and the negative electrons have an attraction for each other. Okay, now this is what happens. Oh, sorry, let me move this over so you can actually see it. So the positive and negatives attract, therefore the positive ions and the negative electrons have an attraction for each other, and this attraction is known as a metallic bond. Okay, so if I go back to our diagram here, this attraction that this electron and positive ion have, that there we call a metallic bond. Okay, and that's how we get metallic bonding. Okay, it's the attraction between positive ions and delocalized electrons. So we'll summarize that up. Okay, so the metallic bond is the attraction between positive metal, positive metal ions and delocalized electrons. Okay. Now, last wee thing I want to write about. Oh, right there. I think I'll leave it there. Okay. So I don't want to give you too much in a single period. So guys, we've done quite a lot of work. Now what you need to take from this is that there are 3 types of bonding: metallic, covalent and ionic. Yeah, you need to know the difference between elements and compounds, so make sure you know that. Metallic bonding is found in metals, so every single metal in the periodic table has metallic bonding. You can't get metallic compounds because they don't exist. If we were to mix different metals together, so if we mixed iron and aluminium, we would get something called an alloy. Okay, if you mix copper and tin, you would get an alloy. Yeah. Now, the whole point of bonding is in order to achieve a full outer shell of electrons, because they want to be stable. That's the whole purpose of it. So neon is stable, oxygen is not. Yeah? So atoms, they want a full outer shell of electrons, so they either want 2 in the first shell, 8 in the second, or 8 in the third. all noble gases are stable because they have a full outer shell. If you look at them in the periodic table, every single noble gas has a full outer shell, yeah? And that's why noble gases don't bond. That's why, oh, might want to add this, due to noble gases do not bond, therefore are unreactive. Okay, and that's why they're unreactive, because they've already got a full outer shell. Now, if we go back to metallic bonding, metals bond by losing their outer electrons. Okay, so lithium has got 3 electrons, so that loses 1 electron to get a full outer shell. Okay, but because we've lost an electron, that's free to move. Same with magnesium. Magnesium, in this case, loses 2 electrons, so that's got 2 free moving electrons. And you should also know that free moving electrons are called delocalized electrons. And you need to know the structure of metallic bonding, and it's that lattice structure, okay? But I'll go into more detail about that when we start hitting into like properties and stuff like that. This here, you need to be able to recognise, okay? Because the SKA will give you diagrams. They might give you a diagram that looks very similar to that, and it says what type of bonding does this show, and you need to be like, right, it's got positive ions, it's got delocalized electrons, it's metallic bonding. Okay, so you need to be able to recognise that diagram. So delocalized electrons are free to move, and we call all those electrons the sea of electrons because they're all moving together like an ocean, almost like the sea. The metallic bond is the attraction between the positive ion and the negative electron, and that's your metallic bond. Okay, so guys, I'll leave it there. The good thing about these videos is that you can pause them, you can rewind them, you can go back, you can watch them again. If you've got any questions, email me, or you can speak to me on Teams. I will be available. But anyway, that's all for today, so thank you.